In this video, we'll review the process for completing the square. Completing the square takes a quadratic equation in standard form and converts it into vertex form. Notice that the vertex form involves a perfect square. In order to create this perfect square, we're going to have to look at the expanded form of a variety of different perfect squares and observe the relationship between the constant term and the middle term's coefficient. Let's start with x plus 3 all squared. If I expand x plus 3 all squared, I end up with x squared plus 6x plus 9. The constant term 9 can be rewritten as 3 squared. If I take 6 and divide it by 2, I get 3, and 3 squared is 9. So it looks like taking half of the middle term's coefficient and squaring it is going to give us the constant term. Let's take a look at x plus 4 all squared and expand it. X plus 4 all squared equals x squared plus 8x plus 16. If I take half of 8, that's 4, and 4 squared gives us 16. So it appears that the perfect square's last term is always half of the middle term's coefficient squared. We're going to have to use this fact when creating a perfect square. In order to complete the square, step 1 is to check the leading coefficient. If a is equal to 1, then you can skip ahead to step 2. If a is not equal to 1, this leading coefficient must be common factored out of the first and second terms. Step 2 is to take half of the middle term's coefficient and square it. Then in step 3, you're going to add and subtract this from the equation. Remember that we're trying to create that perfect square trinomial, but if we add a number, we must also subtract that same number so that the net result is the same as adding 0. Step 4 is to factor the perfect square trinomial, and step 5 is to simplify. This involves taking the coefficient that you factored out and expanding it back through the bracket, and also collecting like terms. Let's take a look at some examples. In question 1, you'll notice that the a value, or the leading coefficient, is 1, so we can skip ahead to step 2. In step 2, we have to take half of the middle term's coefficient and square it. Half of 6 gives 3, and 3 squared gives us 9. So we need to both add and subtract that from the equation. X squared plus 6x plus 9 minus 9 plus 1. So that overall, you'll notice that we're just adding 0, so we're not changing anything. We have created our perfect square trinomial, which we're able to factor to obtain x plus 3 all squared. 3 times 3 gives us 9, and 3 plus 3 gives us 6. Then our last step is to take the negative 9 and add 1 to simplify. We end up with negative 8. So we've now successfully converted this quadratic equation into vertex form, and we can identify that the vertex is negative 3, negative 8. When we take a look at example 2, you'll notice that the coefficient is 2 in front of the x squared term, so we need to common factor that out of both of the first two terms. So we're left with 2 times x squared plus 2x plus 1. Now we need to take half of the middle term's coefficient and square it. So half of 2 gives us 1, and 1 squared is 1. We need to both add and subtract this from our equation. And now we've created our perfect square trinomial, which we can factor. And we obtain 2 times x plus 1 all squared, because we're looking for two numbers that multiply to 1 and add to 2 in the middle. And we still have the minus 1 plus 1. And simplifying, we're going to multiply the 2 back through the bracket. So 2 times x plus 1 all squared minus 2 plus 1. And we end up with 2 times x plus 1 all squared minus 1. And now we've converted to vertex form, and we can see that the vertex for this parabola is going to be located at negative 1, negative 1. In our last example, you'll notice that the a value is negative 3. If I common factor out that negative 3 from the first two terms, I'm left with x squared minus 2/3 x inside my bracket. The next step is to take half of negative 2/3. That gives us negative 1/3, and we need to square it. So we end up with 1/9, and we have to add and subtract this from our equation. So we've created that perfect square trinomial that now we can try to factor. When we factor that perfect square trinomial, we end up with x minus 1/3 all squared in factored form. This factoring was quite a bit harder than in the previous two examples because it involved fractions. Is there a way that we can make the factoring a little bit easier? If we had left the 1/9 as negative 1/3 squared, that's going to allow us to see what that second term in the bracket in the factored form should look like. The last step is to multiply the negative 3 back out through the bracket. So when I distribute the negative 3, I end up with negative 3 times x minus 1/3 all squared. Negative 3 times negative 1/9 gives me positive 3/9, which reduces to positive 1/3 plus 1. And collecting like terms, I end up with negative 3 times x minus 1/3 all squared plus 4/3. The vertex now I can identify for this parabola is located at 1/3, 4/3.